In this module, you will study mass, weight, and density. Learning objectives. State that mass is a measure of the quantity of matter in an object. State that weight is a gravitational force on an object that has mass. Define gravitational field strength as force per unit mass. Define density as mass per unit volume. Recall and use the equation. Describe how to determine the density of a liquid or a regularly shaped solid and of an irregularly shaped solid which sinks in a liquid. Determine whether an object floats based on density data. Mass and weight. They are two different terms, but in daily life, people frequently interchange these terms. Mass is a measure of how much matter there is in an object, while weight is a measure of the size of the pull of gravity on the object. Mass is a scalar quantity and weight is a vector quantity. Weight is a force. If we release a mass from a height, it will freely fall to the ground. The velocity of an object increases during free fall. This rate of increase in velocity is called acceleration due to gravity. The product of mass and acceleration due to gravity is called weight. Measurement shows that on the Earth's surface, a mass of 1 kilogram experiences a force of 9.8 Newton. That is, its weight is 9.8 Newton. The strength of Earth's field is therefore 9.8 Newton per kilogram, near enough 10 Newton per kilogram. It is denoted by g. The letter also used to denote the acceleration of free fall. The force of gravity acts through space and can cause a body not in contact with the earth to fall to the ground. It is an invisible action at a distance force. Earth is surrounded by a gravitational field, which exerts a force on any body in the field. The strength of a gravitational field is defined as the force acting on unit mass in the field. Gravitational field strength G equals weight divided by mass. Mass is universal. You can measure the mass of an object on Earth, or you can measure on planet Jupiter or in Moon. We get the same reading. Gravitational force is different for different planets. We can measure the weight of an object on planet Earth. If we take the same object to Moon, we measure the same mass, but weight will be less than the weight on Earth. Similarly, we can take the same mass from Earth to Jupiter. The gravitational field of Jupiter is more than the gravitational field of Earth. So even though we measure the same mass, the weight will be different. Density. We already know that mass is the amount of matter contained in an object. Density is a measure of mass per volume. The average density of an object equals its total mass divided by its total volume. An object made from a comparatively dense material, such as iron, will have less volume than an object of equal mass made from some less dense substance, such as water. Here we can see rho equals mass divided by volume. Rho is a Greek letter. It represents density. Measurement of density of solid. The mass is found on a balance and the volume by measuring its dimensions with a ruler. If the mass m and volume v of a substance are known, its density can be found from the equation rho equals mass divided by volume. Measurement of density of irregular shaped solid object. If we have regular shaped solid object, it is very easy to find out its volume. For example, for a cube is the volume. Or if it is a metallic sphere, then 4 by 3 pi r cube is the volume. But sometimes we have to find out the density of irregular shaped solid objects. Of course, it is very small and it is sinking in water. Then how to find out the density? The mass of the solid is found on a balance. Now, to find out the volume of irregular shaped solid object, we have to use a measuring cylinder. First, we have to take some water in measuring cylinder. Then by looking at the lower meniscus, we can find out the volume of water. Now, using a thread, dip this irregular shaped solid object in measuring cylinder. There will be displacement of water. And we can measure the lower meniscus of the second reading. Now find out the difference between these two readings. That will give the volume of irregular shaped solid object. So we know the mass and volume. The volume is the difference between the first and second readings, and the density can be found from rho equals mass divided by volume. Here you can see one experimental setup to study or to measure the density of irregular shaped solid object. First, we can find out the mass using the electronic balance. It is 39.21 gram. Second, we can take some water, here it is a colored liquid, and we can measure its volume. It's coming around 47 centimeter cube. Now, after dipping that irregular shaped solid object, you can measure the second reading. It is coming somewhere 57 centimeter cube. So now the difference in reading is 57 minus 47, 10 centimeter cube. So mass is 39.21 gram and volume is 10 centimeter cube. So now the density of the irregular shaped solid is 39.21 divided by 10. We will get 3.921 gram per centimeter cube. You can see another experimental setup to find out the density of given metal ball. In the first picture, you can find out the total mass of the measuring cylinder and the liquid. It is 72 gram. In the second picture, you can see the total mass of measuring cylinder, liquid and the given metal ball. And the value is 105 gram. We can find out the difference between these two masses. You will get the mass of the given metal ball. Now, from the first picture, we can see the density of the given liquid is 40. After dipping the metal ball, the reading is 70. Now find out the difference between these two readings, that is 30. You will get the volume in milliliter. Now you can find out the density using the equation density is equal to mass by volume. Also we can convert this gram and milliliter to kilogram and meter cube. Here you can see another experimental setup to measure the volume of irregular shaped solid object. Once we know the mass and volume, we can find out the density. The mass of the solid is found on a balance. Here you can see an overflow jar. Before dipping that irregular shaped solid object, we take liquid which is about to overflow. After dipping the irregular shaped solid object, the water will overflow and we can collect in a measuring cylinder. Now the reading from the measuring cylinder, that will give the volume of liquid displaced by that irregular shaped solid, which is also equal to the volume of the irregular shaped solid object. Now we can calculate the density from the equation density is equal to mass divided by volume. Measurement of density of liquid. The mass of an empty beaker is found on a balance. A known volume of liquid is transferred from a measuring cylinder into the beaker. The mass of the beaker plus liquid is found, and the mass of the liquid is obtained by subtraction. So the density can be found from the equation density equals mass divided by volume. Finding density of a gas. Finding density of a gas is similar to finding the density of liquid, but we need a highly sensitive digital balance to find out its mass. We can find out the inner volume of this given flask. For that, we can fill this flask with some liquid and transfer that liquid to a measuring cylinder to find out the volume. That volume of the liquid will be equal to the inner volume of this given flask. So first of all, remove the air from a flask of a known volume using a vacuum pump. Find its mass. Now add the gas to be tested, and again you find out the mass. Then the difference is the mass of the gas. Now once you know the mass and volume, we can use the equation density is equal to mass by volume to find the density of gas. Floating or sinking of objects. An object sinks in a liquid of lower density than its own. Otherwise, it floats. For example, a piece of glass of density 2.5 gram per centimeter cube sinks in water. You know, the density of water is 1 gram per centimeter cube, but it floats in mercury. Density of mercury is 13.6 gram per centimeter cube. An iron nail sinks in water, but an iron ship floats because its average density is less than that of water. Low density liquid floats in high density liquids. Hot air balloons and hydrogen balloons. Hot air is lighter than cold air. Actually, these different weather patterns are due to this difference in density of hot air and cold air. You know, if we use air conditioner in room, the position of air conditioner is at the top of the room, because cold air is coming out from the air conditioner. So this cold air will move downward and hot air from the room will go upward. Again, it will cool and come down. And as a result, there will be air circulation inside the room. After some time, the room will uniformly cool. Similarly, in hot country, we use room heater, but the position of the room heater will be near to the floor, because hot air will move upward and cold air from the top will come down and again heat from the heater. You can see another example, hydrogen balloon or helium balloon. Hydrogen gas or helium gas is less denser than atmospheric air compared to other gases. So it will try to move upward. That is why the hydrogen balloons or helium balloons are moving upward. So in third example, you can see hot air balloons. If we go to Turkey or some other places, you can enjoy this travel in hot air balloons. We can see a big balloon and there will be one big basket, and we can enter inside the basket. Using LPG, liquefied petroleum gas, we can give hot air to that balloon. So after filling enough hot air, the balloon will go upward and we can enjoy the surroundings. And if we need to come down, we can stop that hot air. There will be one opening at the top. We can control it by opening that. That we can allow this hot air to escape. Slowly the balloon will come down. Thank you. See you in the next video. If you like, you can subscribe and share. And if you have something to share, you can type in the comment section.